So I've been wanting for a while to do a talk on procedural macros because you end up using them a lot, but you don't end up writing them quite as often. So it's a nice topic to go into a bit more detail on. So I'm going to recap over what procedural macros are, cover why we want to use them briefly, and then the main meat of the talk is going to be the how to write them, what the syntax is like, the tools you have at your disposal to make them a bit easier to work with. So the what, there are three types of procedural macros. There's function-like macros, which take a token stream in and they replace the entire macro invocation token stream with their own, whatever the macro outputs. Derived macros, which are the custom derive, might be the name of your custom derived macro, which you could write, which would create new items given a token stream of a struct, an enum, or a union. So if you've used the copy trait or the clone trait, you probably haven't implemented it, or you probably will have implemented it yourself, but a common way to do it would just be to use the derived macro for clone or the derived macro for copy, which will look at your struct, look at your enum, look at your union, and implement that trait for you. And the way it does that is by using a procedural macro. There's also attribute macros that can be attached to items, so structs, functions, traits, and in that case, the token stream returned replaces the item with an arbitrary number of other items. So if you've used rocket, then you might have a rocket main function, which you might annotate, and the rocket macro will generate all the functions that you need based on the function that you've input. Taken these images from a JetBrains blog. They give a kind of nice summary of those three types I was describing verbally. You can see if you write a procedural macro that's designed to be a function-like macro, it's going to take the body of, so whatever's between the parentheses in your invocation of the macro, take that as a token stream, and then output a token stream that's going to replace the entire invocation. So this input token stream is just equivalent of parameters for a function, but then they don't have to be Rust code that would compile on its own. You could put whatever you wanted in there as long as it's a valid token stream in Rust. Then there's the derived macro, which again takes the body with a token stream, but in this case, that token stream isn't you're not using it as like a function call. You're going to do it like as a type annotation. So if you have your struct, this you would have hash derive bar that then would read your struct, as we're going to see later, and then take that struct as the token stream. And then finally, the attribute macro, where in this case, it's going to take a function and then it might replace it with any other code, some other token stream. So what is the token stream? Well, it's just a sequence of token trees. Token tree could be a group, which would be another token stream, but surrounded by bracket delimiters, an identifier, punctuation character, or a literal. And as well as its data, each of those tokens has a span, which is what you use for error reporting for mapping to the correct lines, which we're going to get onto later. So this is another image from the JetBrains blog, which I will link in the chat later. Here you're calling a function-like macro. It starts with some kind of identifier. So this token stream can be split up into taking an identifier, then a group. You can see that 2 + 2 is a token stream in itself within a group, and then finally another identifier. And that's how it would kind of spread out in the context of the token stream, and that's how you would read it in. So it's less of a stream and more of a tree-like structure because of that grouping with the brackets. So why are we using procedural macros? Because they are bit more complicated than some of the other things we've touched on in Rust. Well, they allow you to run code at compile time and operate over Rust syntax, consuming and producing other syntax. And that's a really powerful thing to be able to do. So as well as the normal case of reducing boilerplate code with things like the copy trait and the clone trait, they can also simplify APIs. So you can make things that would be otherwise very difficult to use much easier. And that's what you'll see with things like Rocket. And they can also allow you to expand the language syntax with custom constructs, because the code in between those brackets doesn't have to be strictly valid Rust. It doesn't have to be Rust code itself. So an example would be someone's created this crate called UHTML that allows you to basically write HTML inside your code. So that's sometimes used for writing web front ends in Rust, which I know isn't that common a use case, but people can do it, and they do it. So this allows you to have an HTML parsing macro. So I can start my HTML macro, and then within that code, it's just a token stream. It happens to not really be Rust code, it happens to be HTML code, but within the macro definition, it will do all the HTML parsing for you. So it basically acts like an HTML parser, because it is. And then it can expand that into the equivalent for Rust code. So you get to write more familiar HTML code, and the macro will turn it into the kind of Rust code that you need in order to have the same effect. So now we're going to get into derived macros. Just check the chat. Someone said use really useful for generating web pages using WebAssembly. So yeah, people do use it. Very useful. So as I've mentioned, derived macros are invoked with the pound square brackets derive and then the name of your derived macro. And you create them by annotating your function with proc macro derive and then the name of that derived macro. So taking an example of one that we won't be writing that already exists is clone. So in the example of, say, having derived clone on like some struct, some type, some unit type, when we look at what clone's doing, it's not immediately obvious what's happening, but we can use cargo expand to make it a lot easier to tell what's going on. So cargo expand is a tool that's available, and you can download it from crates.io, and you can run it on any part of your code and expand macros so that you can see what's actually going on after a pass of the macro. So in this case, it's expanding to, it's saying automatically derived. This implementation block was automatically derived. It's implementing the clone trait for that type, and then it's generating this function for us. In our case, there's no data to do anything on, so it just can return a new instance of that type. But if it was a type with fields, so for example, in this case, we've got a string field, it's going to call the underlying strings clone method. So it's able to look at any of the fields that you've written, and just by annotating this with derive clone, it can figure out how to write this function. And that's the kind of thing that we're going to be writing by the end of this talk, hopefully. So now we get on to the meaty bit, which is how. Actually, before we do that, I'm just going to switch over to show you what the cargo expand looks like. So when I run cargo expand on this clone trait code, so you can see here I've got the struct that I mentioned. This one actually isn't a unit struct now because I've got the curly brackets in. It's a field type struct with no attributes in it, but you can see I've got clone, I've got debug in there. And by implementing the clone trait, I now get access to this method. When you look at what it's actually expanded to, so it's that code that I was showing you earlier. So you've got the struct itself here, and then you've got this clone method. And then this here is to do with implementing the debug stuff and remove, and then you can print out things. So that's two traits that we've kind of derived there. Cool. So switch back. So unlike declarative macros, so those are the macro rules macros, procedural macros have to be defined in their own crates. And that's because the crate itself needs to have the type proc macro, which means it needs to be compiled with the flag crate type proc macro. The main way you'll see this done is using cargo, because we use cargo for everything. So in the cargo.toml, we're just going to add lib proc macro true, and that's going to allow us to write our own procedural macros. In this talk, I'm not going to be talking about writing macros with no tooling, with nothing. I'm just going to launch straight into using the sin and quote crates, because those are the kind of gold standard used everywhere to write pretty much all procedural macros. So sin is a parsing library for parsing a stream of Rust tokens into a syntax tree of Rust source code, and quote provides a quote macro within which you can write Rust code that then gets packaged into a token stream. So they go hand in hand together, going each direction. And any type implementing the quote to tokens trait can be interpolated using the pound var syntax. And crucially, that includes most of the syntax tree types from SID, which is why they work so well together. When you're writing procedural macros, you just need to double check that you're using compatible versions of those two crates because they do go so closely hand in hand. So let's start with a really simple example. We want to write a macro which prints the abstract syntax tree of the struct during compilation when we write derive print AST. So it's not going to do anything to our runtime code. We just want it to do something at compile time. So we need to create a separate crate. We need to mark it with proc macro true in the cargo.toml. And then we need to actually look at writing the code. So we're going to use the token stream type in proc macro because this is a proc macro crate. We can include that. And then we're going to use syn for the syntax parsing. We're going to take parse macro input and derive input. Here we take the token stream as the input. It's going to be some kind of derive input because this is a derived macro. We're going to generate an abstract syntax tree, and then we're just going to print it. And this ePrint line, so that prints to the error output, which means we'll get to see it at compile time. Otherwise, it would just be swallowed. You wouldn't see anything. So, and it's worth noting to get access to this function. So in order for the AST to implement debug print, we need to add in the extra traits feature when you include the crate in your cargo.toml. And then if you do that, then you end up with something looking like this. I'll show it in Visual Studio Code in a second. The few things you want to kind of draw your attention to. I'll start off with the identifier. So this is the name of our type that we've created. And as well as having the fact that it's an identifier with the string version of its name, it also has the span, and that is the part of the original code. These bytes is what it refers to. It's a part of the original code that defines some type, so those actual characters. There's the generics part, which I'm not going to get onto in this talk, to do with handling generic parameters, things like lifetimes. And then there's the data itself. So if we have a unit struct, or if we have a data struct but with no names in it, then our named fields is just going to be empty, but it'll still know what type it is, and we can burrow down and get information out. So just seeing that in action. Oh, so not cargo expand, we want to do cargo run. So there we have printed the syntax tree. So again from earlier, so I had a ... in here where the attributes are. We'll come on to this in a second as to what they actually are. But you can see we've got the data down here, and then we also have, what are we operating on? So our type here is some type unit struct. Oh yeah, no, sorry, data, which I was at earlier. There's the data struct with the named fields in it. Okay, so those attributes at the top that we didn't actually end up digging into, they have several different forms, so 6 different forms. They could be the outer attributes, so for example, allow unused. They could be inner attributes inside of the item they describe, like allow unused variables. It could also be things like dot comments, so outer dot comments or inner dot comments, or outer block comments or inner block comments. And this seems like, why would you want to use this information? But actually it's very, very powerful to have access to it, and it's very, very useful. The classic example is clap, which I think one of the earlier chapters in the book used, where it's used for command line parsing, where you can define a struct with your arguments, and then you can use that to parse your arguments. As well as being able to parse the arguments and giving you that capabilities, what's really useful about it is it takes these documentation comments and it turns it into proper documentation for your command line tool. So if we switch over to that example now, you can see if I do cargo run, it's not going to work because I haven't passed in any command line parameters, but what it is going to do is say which parameters weren't provided. And if I pass in -h to ask for the help, then, sorry, then it's going to say this is a simple program to greet a person. And if we look at the code itself, you can see it's pulled that straight out of the doc comments, which is really useful. And again, this is just another use of procedural macros, the derived macro, where it's using the attributes in the token stream, pulling that information out and turning it into something really useful. Similarly, for this one here, name of the person to greet, you can see that ends up getting outputted there. She's going to check the chat for any questions. Oh, Matt says he's going to cover clap. Awesome. That'll be, yeah, it'd be nice to get a bit more detail on clap. It's a very useful tool. Okay. So that's just the example there. When you do cargo run and request the help, it's pulled out those comments. Okay, so let's actually do something with it ourselves. Let's use the token stream. So far, we've just printed the token stream, but we haven't actually done anything with it. This is an example. So let's say we want to implement a trait called greetings, which has a function which takes hello and then prints hello from, and then whatever the type name is that it's been implemented on. To do that, what we're going to do is we're going to be including many of the same crates as we were before and modules from before, but we're also going to be adding in quote now. So similar to the last one, we've got the proc macro derive, so that we've declared it as a derived macro. We've got the name that's going to appear in the brackets of what we're deriving when we invoke it. And then we've got the token stream. We're again going to parse the AST using the SYN crate. But now what we're going to do is we're going to get out the identifier from the AST. So just like in the example where we printed the AST, where you could see at the top level, it gave you access to the identifier. We're going to use that to then use the quote crate, which has a declarative macro in it, to just write some basically vanilla Rust code. So we're just implementing greetings for, and then our type name. And this isn't just a string here. This isn't doing like kind of string find and replace. This specifically is an identifier, and it gives you access to things like span and other information that you need as part of the syntax tree. So now we can print hello from the identifier, and it's just gonna work straight out the bat. So let's see that in action. So we can see deriving greetings on some type, and that's just because I've got an additional print statement in there. So we go into derive greetings. You see I've got a little error print to just check that it's working correctly. And then it says hello from some type because I'm actually calling it. And if I do cargo expand, which can be useful sometimes if you've made a mistake on your macro, so the end result of the code isn't compiling, you might want to have a look at what the code actually is to help you figure out what you might have done wrong. Typo, Cagro. So when we call cargo expand, we can see we get that implementation block, which takes self and it's implemented on our type. And that's why we can call hello.
We've got a question in the chat, Ciara. Just seems pertinent to do it before we get too far
away.
Yeah,
into. Okay, so the into is a slightly interesting one. The token stream here is not the token stream that quote returns. Quote returns a token stream 2 from proc macro 2, which is a crate that basically it exists outside of Rust so that you can do things and treat it like a regular library. But in order to actually feed that back into the part of the compilation process, you can't return token stream 2, you have to return a token stream. I think it might have some additional functionality, token stream 2, but the haven't really had to use it other than the fact that you can convert token stream 2 into token stream, and then it will work.
As a general explanation, the into function is part of the into trait, which is part of the standard library, and it basically allows you to convert from one type to another. You'll see it all over Rust code.
Yeah, so for converting from one type to another, that was the token stream 2 has done that implementation for converting from token stream 2 to token stream. It's not something that you just get for free in order to implement into, but yeah, that function you're right is used all over, especially for error messages. That's the classic place you see it all the time, converting between errors. Okay, I should say them here. So let's get a bit more detailed. Let's actually try and parse some fields out of our struct. So let's write a simple macro to print struct fields and field types at compile time. So it's still not doing anything too fancy. It's just printing some information, but some specific information at compile time. Going to do something, again, very similar to what we did before. Got the derive, the name of what we're deriving, taking an input token stream. But now we're going to start interrogating the data a bit more. So whereas before we were just getting off the identifier, now we're going to burrow down into the data. The data itself is an enum that we can match on. In this case, we want to match on struct type. If we wanted to handle other types, we would have to handle all of those separately. We're then going to match on the fields, get the fields out, and then iterate over the fields and print them. Because we don't want to actually create any more code, so we're not creating an implementation block like we were in the previous one, we can just return an empty token stream because we don't want this macro to cause any code changes. We just want to print it at compile time. So having a look at that in action. So cargo expand hasn't actually done anything. We've not expanded anything new because we've just we've put out an empty token stream. But we can see when we do cargo run that we're printing out these fields at compile time with their type. So I just want to talk a little bit about the code itself, because it ended up being a little bit more involved, the printing logic, than I was expecting. There might be a cleaner way to do it. So if anyone knows a way, then let me know. So I showed in the slides up to this iterator and then said printing logic. The printing logic for getting the identifier was easy, but then for getting the type, you end up having to burrow down a fair few levels to get to the type itself. So you end up with a match statement on the type. Then that returns, if you want to get the identifier, that returns an optional. So you then have to unwrap that and then you have to print it. So you probably end up breaking this out into a helper, but because we saw from the earlier, the abstract syntax tree does have a lot of things in it, which is why you have to end up burrowing down. I'm going to come on to the unimplemented later, but that's just that I haven't implemented that part, so it'll throw an exception at compile time if I try and go into any of those branches. Cool. So, any more questions? Just some information. Cool. We're going to look at a slightly more involved one, but not too much more involved, but just deriving a constructor. So we're going to combine what we've done in the two previous cases of extracting the fields and returning code using quote. So the end result code we want is that we can have a struct with private fields, field 1, field 2, and when we use it, we want to be able to have a new constructor that's automatically derived on that type that takes all the fields. So it's not a hugely complicated type to just implement yourself, but this way you could just add it to any struct that you wanted. So we're going to have a think about what code we actually want. So if we were hand coding this, then we would write, an implementation block for the type, public function new, and then each of the fields with the type. We probably have these names match the names of the fields internally for simplicity, but obviously if you wanted something different, then your macro will just get more complicated. So that's how we're doing it this time. And then we're just going to create a new instance of our struct and return it. But crucially, we want it to be for any number of fields. So we'll start with the same code as before to parse our fields. It's slightly refactored, but it's the same code where we're getting out the fields here, which come out as a punctuated type, which implements iterator. So you see here, fields iterator is the type that we're actually returning. I'll go through this code in a tiny bit more detail just to show. So this is an if-let block of my type struct, and I'm basically deconstructing the AST data to pull out the internal names. So I'm saying I'm going to try and match this enum struct, which contains this enum data struct, which has a fields object on that struct, which has the enum type named, and then I'm going to pull out the named field from it. So it's slightly wordy deconstruction, but it saves on lines of code so that I can fit it on a slide. And then that's the AST data, the abstract syntax tree data. So now that we've got those fields, you might think, well, what's the benefit of having that fields iterator? Well, the quote macro actually allows you to leverage that. So what we're doing here is we're taking our fields and we're mapping them. So we're having an iterator over it and we're mapping them onto it. So to start with, we're only just creating a simple, the name, which we've extracted from the identifier, and the colon type. So you can see this is going to be our constructor parameters. It's going to be name colon type, comma, name colon type. But so far we haven't put in the commas. We've just converted our fields iterator into this name colon type iterator. So we haven't actually done that yet, but we've defined the mapping. The next thing we're going to do is describe the constructor initialization. So again, we're taking the fields iterator and we're saying, okay, get the identifiers, and we're just going to have the name. That's all we actually need here. And the reason this is useful, because now we've got these iterators that have the form we want, that we can take advantage of quotes handling iterators to expand those iterators into the code we want. So normally, so what we've seen before is that with the quote macro, you can have this $var to do variable interpolation, which is similar to $var in macro rules macros. And the rules it's defined behave exactly the same. Not exactly the same, but very, very similarly. So for simple cases, it will pretty much look the same. So here we have pound, open brackets, and then $var, and then close brackets, and then the star. So if we have our iterator on the outside, what this will do is expand the iterator with no separators and just do them one after the other. If we put a comma in there, then it will expand our iterator with commas between them. And we can actually use other tokens in there as well. So you could write struct $var semicolon, and then the expansion then would contain all of those for each of our items in the iterator. So now we just need to use that to expand our constructor parameters and our initializing fields with comma delimiters. So we're using those, the quote things that we created earlier, which were the mappings from the fields to our little quote blocks. And now we're using another quote block for our actual final implementation block. So we take our identifier, which was just our type. Then we're saying public function new, and this is the expansion. So the constructor params were name colon type, but now they're going to be comma delimited, and we're going to have one for each one. We're returning the same type as the identifier, and we're constructing a new version of the identifier, a new instance of the identifier, which is just some type, opening curly braces. We've got our mapping from the fields to the constructor initialization, which if you remember was just the field name, it didn't have anything else. But now it's comma delimited, so we've actually got all of our struct construction parameters in there. And let's actually see that in action. And if anyone's got any questions, we can go over those as well, because it is a bit of a funny thing. If it's the first time you've seen it, it does look a bit odd. So let's look at the code in the macro itself. So we've got constructor as the name of the derive attribute, taking in the token stream, constructing the abstract syntax tree by parsing it with this macro. Going to get out the identifier, and we're going to get out the fields, which were inside the abstract syntax tree data. We just had to look at the structure of the abstract syntax tree to parse it out to get one of the fields inside this field's named. And then this was the interesting bit. So because we want to do this later, we want something that's going to expand to a comma delimited list of the constructor parameters. So that's why we got the name out from each of the fields and the type out from each of the fields, so that we could write name : type. And then similarly for the initializer list, this is the shorthand syntax for struct initialization when the names match. If you didn't want the names to match for some crazy reason, then you would need the full syntax for initializing the struct, but because the names do match, we don't need that. So that's then just the comma delimited list of the constructor initialization. And then once we've got that final token stream, we can then return it. If we look at where we're actually calling it, we've just written derive constructor. And now, even though these fields are private, because this is hidden inside another module that we don't have access to, all we have access to is the type that's made public, we can now call some type new, and we can construct those fields in the order of the fields in the struct and with those names. And if we look at the cargo expand, you'll see that it's just generated that function for us. So it's generated the new function, which just looks exactly like if we'd written it ourselves. It's very, very simple, but effective. So if I had many structs that I wanted to do this on, then I could just quickly add in this particular trait and it would give me that constructor. Cool. Any questions at that point? So how did they write sin in quote without the use of sin in quote? It's a very good question with difficulty. Yeah, C++ macros are very different as mathematics. Matt, you've dealt with all these questions. So yeah, the why use macros in the first place. I'll go back at the end just to go through those whys, so we can maybe see how much work's probably gone into writing some of those macros when you see the faffery that goes on to get them to work. Although because of the quote macro, it's actually very clean for simple cases, which is really nice.
Well, you can also see here the examples you've shown that actually generate code. Why would write a new function when you can have the compiler write it for you?
Exactly. Yeah. If you know everyone's going to be writing it with the exact same pattern, if you can define in your mind how you go from that type to this function, then why not write a macro for it rather than writing it 50 times? And then we can do the same trick to write setters for our fields. So there's nothing new going on there. Sorry, actually I'm writing getters, not setters, but it would be very similar for setters. So I want to derive getters so that I can get out field 1 and field 2. And just to be clear, I'm not advocating that you write these and use this for your public and getters and setters, but if you wanted to, this is the syntax that would do it. So let's head into the macro itself. Again, taking the token stream, getting the abstract syntax tree, getting the identifier out, matching on the fields to pull out the data. And then to create the getters, we've got the mapping of the iterator, extracting the name and the type from the field. And then within our quote macro, we're now going to add in a little snippet of code. This time it's a bit more involved. Rather than before we just had name : type, we've now got we're creating a new function for each one. So we're saying public function with this name, taking self, returning a reference to that type, and then returning reference to self dot name. And this works. In our then final returning quote, we're taking all of those functions and we're just expanding them. So they're just going to be put one after the other. White space doesn't get stripped out of all of these things, so you don't need to worry about putting it on a new line or anything. And the reason why cargo expand is nice is because it puts back in those white spaces, so that the code you're looking at when you do cargo expand isn't just a big mess of syntax. So in this case, now when we do cargo expand, as well as getting that constructors, oh, I didn't actually switch over. So switch over to this one. Now when we do a cargo expand, we're going to get these new functions in a new implementation block that have the functions to get out each of the fields. Cool. So now the final section I want to talk about is reporting errors. So far, we haven't actually done any error handling whatsoever. When we've been doing those match statements, we've just been putting unimplemented on the blocks where things weren't implemented. So just to show you what that looks like, if we take the constructor case, for example, and we change it so as well as having a struct, for example, we could have an enum. So, and then let's say we wanted to derive constructor on this. Well, that's nothing we've written so far is going to work for an enum. The error we get is just that the macro derive panicked and the message was not implemented, which is, in this case, it doesn't, maybe it's fine, there can't be a constructor, but in more complex macro cases where there might be some specific constraints on your types that it's going to support, if you try to do something that doesn't make sense, you want to know what's happened. So say, for example, instead what you had was some unnamed fields type, which is a struct. So in this case, I've still got a struct. It could have constructors, but I can't implement the type on it. And it just says not implemented. Oh, sorry, types. So now when we do it, we're still going to get errors. I don't know if I did a comma. Oh, curly braces. So I've turned it into a tuple-like struct, which is a perfectly valid struct. Would be a perfectly valid struct. But it's not going to work. And if I switch this actually to use it again, we're not even getting an error for this one, but we definitely haven't implemented it.
That's a normal struct. That's why you don't get an error.
Oh, but okay, yeah.
You want to get rid of the T1, T2 and add the parentheses back in.
Add the parentheses back in. Sorry, my brain. So now I've written a tuple struct. And now I'm getting an error that it just says message not implemented. So so you can't use a constructor for a tuple struct where the fields don't have names. We basically want to replace that unimplemented block with something useful so that we can tell the user how they're using the macro wrong. This is the example we just looked at. So if you actually ran there, I was just using the IDE to show me the errors, but if you ran the compiler, then these are the errors you would get. Message not implemented. But we can add our own errors, which is what we're going to do now. And we can do that with the help of the syn crate. The way we're going to do that is by creating a helper method that's going to return a result with error type syn error. And that's going to allow us to bubble up errors, which also use the span, because this error type is going to have the span in it, and the span is the bit of code where we want to report that there was an error. So which bit is wrong? So here I mentioned the token stream 2, so proc macro 2 token stream. That's the type that isn't the one you want to return from your macro, but you can use it in between, and then you do into at the end to convert it to the correct type, because that's there. So let's take, for example, a unit struct. So one which doesn't just have unnamed fields, it has no fields. It's just a unit struct toy type. We're going to return an error. We're going to create a new error, and we're going to put the span as the span of the identifier, because there's nowhere else really that makes sense to put the error other than on the identifier itself. And we can put an error like expected name struct, but we found a unit struct. And if we do that, so we now emit the errors, then when we do cargo run on our emit errors case, which has a bunch of different error types, then we can get those errors to report in different locations. I'll go through how we're doing that again by going into the macro, but we can just see here what we're actually ending up with. It highlights here, in this case, the first parameter of our tuple struct, because we could have put in a name there. We could also, if we wanted, done the span on this bracket by getting out the span for the bracket. We could really put this kind of wherever we want. And we could say expected name struct found tuple struct. In the case of a unit struct, we can say expected name struct found enum. If we look at what the macro is doing, it's by no means a polished macro. And the error handling is not what I would recommend for error handling, but it just shows you the tools available. Please don't take this as best practice. So similar to before, so in the actual macro itself, so my proc macro derive constructor, this is still just returning a token stream, but I've now kind of deferred the work onto my helper method derive constructor implementation. That's going to return a result type, which I can unwrap. And if it finds an error, then it can convert that to a compile error. And this is something that exists in the syn trait, and that's the one that does the creating the compiler error for us. In the actual logic itself, we're getting the data out. Similar to before, I'm now doing a full match so that I can go through the cases where it fails. You can see I haven't done most of them, but I have done one for path, which actually I think in this case might be the only one I need anyway. But we're going through the path, getting the segments out, and this is just the nature of the nesting of the abstract syntax tree. These are the levels we have to go down to get to the identifier, which we want to use in our error message. So we've gone down, we've then unwrapped it, and we've gotten the span out, and then we're setting this span into the span that we want to use for our error. And then here we're returning an error using that span, and we're saying expected name struct found tuple struct. Similarly for unit, but this time there are no fields that we want to burrow down to do our underline on. We can just use the top level identifier, so we don't need to do any of that burrowing down. We can just say identifier span, expected name struct found unit struct. And similarly for enum, so we've got the identifier, so we can say expected name struct found enum, and it will report that on the span of the identifier that we gave it from the AST, which is pretty cool. And it's not, it's not that hard to do. You just end up with kind of some fairly ugly code, but you could break that out into helper methods and make it a lot cleaner and manage it a lot better. So that is how you can, if you want, report errors when you're writing your procedural macros. In the process of writing them, like if you make a mistake, I'd say cargo expand is really useful for the end result, ending code. Like I think I missed out self on one of my methods, and it's not as obvious because you don't get any error messaging in your proc macro itself. So if there's something wrong with your Rust syntax code in the thing you're trying to expand, you don't get those error messages. But once you've seen it expanded as like, okay, this is what it looks like once it's used, then you can start to see where things have gone wrong, which is nice. So this is just going through that example that we went through in Visual Studio Code, unwrapping the results, converting it to a compile error using the create helper method. And that gave us the control over the error messages. So conclusions. procedural macros are extremely powerful. You get full access to all of the information about the abstract syntax tree. You can interrogate the types, you can burrow down, you can get the data out. You can look at where the brackets are, you can look at everything. I'd say they're much easier to use than they are to write. The user of the macro is the first class citizen, which is why things like you want to write good error messages. You want to make sure that it's obvious where you should be using these macros. But the quote and the syn crates make writing those macros way, way easier. There are some considerations you need to make to do with like safety, because macros are run at compile time and they have access to a huge amount of stuff. They can be, it'd be not that difficult to write some malicious code and things like that. But they are really, really useful when they're done with good intentions. Okay, so that's I think the end for me. I've got some like resources that I found helpful. There's a procedural macro workshop, which I think I mentioned before and linked before. There's the Ferris Systems have a blog on testing procedural macros, which I didn't get into in this talk, but if you are serious about writing your own procedural macros, you want a good test harness. Crust of Rust is a YouTuber who does some really great videos. He's got two parts 1 and parts 2 of procedural macros, like 4 hours and 5 hours long, but they are good. I haven't watched all of them. I've watched like 4 hours of one of them. And then there's the JetBrains one, which I gave some images from earlier, so I'll drop those links in the chat. And that's me. I'll put those links in the chat. Does anyone have any questions? I can try and answer, or want me to go over anything that I went over just then in a bit more detail or slower? Silence is either good or bad. I don't know which.
So you said that they're a lot more fun to use than to write. Is there like any recommendations you have for how to write a macro if you sort of know what you want to do? You kind of sort of showed us how you put the parameters in. The one where you did the parameters. You kind of sort of showed us the code that you wanted, and then from that, is there a way to get to the macro?
That I think is the easiest way, is figuring out the mapping from your inputs to your outputs, and then after that it's just normal boring software, the dull bit of software. You figured it out, you're like, now I just need to to
figure out where in the token stream it is. Yeah,
exactly. And printing the ASC I found really helpful for figuring out the levels down, so if you include this one, so if you include features extra traits on the syn crate in your cargo.toml, then you get access to this print, and that can be really helpful sometimes if you're like, how many levels do I have to go down to get from this to this type? But I'm by no means an expert on writing procedural macros, so I'll be interested to see kind of what everyone else comes out with afterwards, and if they want to come do a talk on it, because they are really useful.
Actually, you mentioned the most important part is to actually write the code you want to generate first, and that'll give you a very good idea. And then syn makes it easy to read the stuff between the macro brackets, and quote makes it really easy to output Rust code. So the hardest part, I feel, is actually generating, figuring out what the code you want to generate is. And once you've done that, you're 50% of the way there.
Yeah. And you'll be able to throw away a lot of things. Like in the error handling, I know it looked like I had that huge list of cases I didn't handle. But actually, most of those you probably wouldn't need to handle, because I know that this is only happening in a certain context where all I'm going to get is one of those types. So I could actually probably have grouped a lot of those and said, for everything else, this should never happen. So it's fine to throw an error. That was in the error. These ones here. I probably know, I know I'm never going to get a macro there. I know I'm not going to get any of these here. So.
And then the other thing, I was just with the repetition operator where you had the comma at the end of it.
Mm-hmm.
So I noticed that actually is like, so what's in the parentheses kind of gets repeated, and the comma is like, because I thought, will there be a comma at the end of the whole list or not? And it seems like there's not. So
no, if you put it inside the brackets, there would be a comma at the end. If it's inside the brackets, then it's not. So it's basically, this is like your concatenation character, where it's like concatenating them together. If you put it inside, then it's part of the repeat. In example, so you can actually, you could write even as complicated things as struct bar semicolon. That will be there every time for every repetition, and then there's no delimiter here, so you wouldn't get anything else in between, which is fine because it's semicolon delimited already, and everyone does have one at the end.
It's also worth noting that the a trailing comma is accepted in Rust in pretty much everywhere. So
Also
it wouldn't be
true.
a syntax error. So if you're feeling lazy and you don't want to put it outside the parentheses. Even Rust format inserts that comma for you, so you have no choice.
Yeah, makes your diffs easier on Git if you add a new parameter. Motivator. Seen some advice for having a leading separator instead of a trailing separator. That's another conversation for another day of style choices.
Thank you, Ciara. May I ask a beginner's question with Rust, with macro rules? What if I'm actually not getting any expansion because the input is not matching my macro rules, and I cannot easily? Do you know of any tricks to figure it out? If you know the compiler is saying, oh, you know, this token stream basically is not matching because it's expecting some whatever segment or fraction, and you know, especially when there are repetitions or whatever, some tokens can only follow specific ones. Any tips on the macro rules figure syntax troubleshooting, please?
My advice would be build up slowly. I think if you do it bit by bit, and as well looking at writing unit tests, so that the posts are linked to do with unit testing macros, I think is really useful. If you can start to like build it up piece by piece, then you're kind of your own debugger. But I know what you mean. That is what makes macros harder, is you don't have the full end result to look at. It's not going to give you quite as nice error messages.
Thank you.
Yeah, because macro rules is declarative, there's very little. It's difficult to put imperative stuff in there. In fact, you can't. Whereas you write in these procedural macros, you have a bit more of an advantage because you can insert your print statements or log statements.
But the benefit of macros is that hopefully the end result will be much more maintainable once you get there, because there's only so much you can do with a macro rules macro, and they might not be as easy to like print statement debug, but they should be easier to like eyeball debug. Hopefully, if you scale it up slowly.
I have a question. A closure that doesn't take any value is just like it's a way of making something callable, and then it's related to callback. So in Java, there are callbacks everywhere, and we don't talk a lot about callbacks in Rust. So anyone can talk a little bit more about that?
I can say something if you want, Ciara.
Yeah, the only thing I would say on it is I feel like it's context dependent. When you need callbacks, you use callbacks, but I haven't used Java, so.
I would say Rust uses callbacks all the time. One of the common areas that I see callbacks is in iterator use for like filters and maps, where your callback is getting called on every element. Does that make sense?
It may be more the terminology, because Rust almost always calls it closures.
Closure is the original name, right? And another language is later. Closure comes from really early Lisp days, and then later you get like, Lisp really uses the term lambda, which C++ tends to use as well. Closures is a special type of function which it's derived from the idea that you close over some input parameters. So you keep the input parameters. So there's some state along with the function. But yeah, other languages call it. I forget what the other terms are. It's callback, but I've heard some other terms as well. But they're roughly all the same thing.
So a closure is a callback.
Not quite. Closure is a bit more than a callback. A callback, it depends when you usually talk about callback, you're talking about a normal function. So a normal function could be a callback, right? So it's basically a callback refers to the idea that you provide some sort of functional object to be called when a certain event happens. That can be a closure, that can be, or a lambda if you're using C++ terminology, or it could be a function. But the term callback is more of a concept where you want to customize something. So when this event happens, I want you to call this functional object and do what I want it to do.
Okay, got it. Thank you.
I think one of the reasons callbacks aren't used quite so much the same way as in Java, as they are in Rust, is that in Java you often pass a callable into an object and kind of store it there in the object. And in Rust, that can be problematic because of the ownership issues and to sort of take a struct to store a closure, because you can't name the type directly, so you have to box it, which then gets into Rust people's fear of allocating memory. And so kind of like people work around that kind of model of storing callbacks somewhat in Rust.
I've managed to go my entire career avoiding Java, so I'm not a Java expert at all. And I'll be happy to continue the rest of my life avoiding Java.
I think like with any kind of language feature, if you don't use a callback just because you think you should use a callback. I feel like what it's all context based. So if there's like a context where you're like, I use a callback here in Java, but I can't use it in Rust for some other reason, like the example you were giving there, John, of like it's hard to store on a struct or without using a box, then you might think, okay, well, what is Java doing? Well, it's definitely heap allocating as well. So actually, to get like for like, I'm going to have to do the same thing, and then maybe look at other techniques.
It's pretty common in Node.js as well with JavaScript. Because usually with a lot of asynchronous stuff, that you want to do something, it will go off, and then you'll want to call something when something's finished. Does Rust really support that? I don't know what Tokyo does, but it normally some libraries is like the then operator, where you say I want to do this, then I want to do this, then I want to do this in asynchronous programming. But I'm not sure if Rust does that very well.
Just have something like that, I think. Yeah, then operator.
Not part of the standard library, though, is it?
Well, it's part of the futures, I think, the futures library.
Is it really? Okay, I'm going to look up that. Thank you for pointing that out.
It might be end then or something like that.
Yes, it does ring a bell. I probably wrote in a blog about it as well, because it does ring a bell. It was a long time ago, so I've forgotten most of my stuff I've written about.
Cool. Well, we kept remarkably on schedule, so pleased with that. Yeah, if anyone has any questions, then yeah, feel free to reach out on the Discord or anything, and I'll put those links, as you say, Matt, in the YouTube when we post it. There are a few videos behind now. Actually, I need to post those.
Yeah, I've noticed none of my videos are done. I get the hint. Okay, I get it. I'm leaving. Okay.
It'll be up soon, I promise. Blame it on my internet speeds, avoiding uploading it.
But yeah, I think you need to buy us a drink first. That's how it works.
Thanks very much, Ciara. That was a good talk. I learned quite a bit there. specifically the use of quote for the this current slide here. That was quite cool.
Yeah, that's when I saw this, I was like, this is just such a nice, useful thing that it really does extend the capabilities of it quite a lot. And yeah, next week Alex is going to be doing a talk on C++ concepts versus Rust traits, which is going to be great.
Ooh.
And hey, now I love C++ too.
It's not the same thing.
It's not.
Versus implies a winner, Matt. So maybe you need to come along to root for your favorite.
I'll make a Rust flag just for the occasion. I can wave it. No, I'm very fascinated by that.
Cool.
I was thinking some of the sort of programming sessions, rather than doing an actual talk on it, maybe I could do it as a Discord stream. So choose some time and I'll just switch on my screen share on Discord. Anyone that wants to can just follow it. But then I won't be able to upload it onto YouTube or anything like that. So I'll have to think about what I need to do about that.
Yeah, you can maybe do the screen record on your end as you're sharing or something, and then get it to us, upload it to
maybe OBS or something. We'll see.
Yeah, that sounds good. And then just drop us a message on Discord when if you have a date in mind, and we can definitely get an event up for it so people know what's happening as well.
Is that something that interests people? Live coding, where you see me make lots of mistakes and try to figure out exactly where I went wrong.
Getting some nods that you can see them. But
okay.
Very enthusiastic.
I'm ready to embarrass myself.
And to everyone else, if anyone else has got any talk ideas or anything you want to force yourself to learn about, it's always a good trick. We're a very friendly group.
Well, this is it. What I'm going to be programming, I actually have to learn a few crates and learn how to do a few things just by doing the tool. So I would recommend just pick a tiny little tool you want to do and then just figure it out. For example, I discovered a really cool crate called directories, which allows me to find where the temporary directories are or the application directories are to save configuration files. So Windows have been the app data folder, in Linux have been your .config folder and things like that. And so I didn't know how to do that, and I had to figure that out by doing this tool. So I recommend, if you want to learn a language, please figure out some sort of small thing and then share it with us. And then because I'll be fascinated to see other projects.
And just to add on top of that, so there are all skill sets are welcome. So just because obviously whenever Ciara talks about anything, she always seems like our grand guru, especially lately after going through so many of the Rust chapters. But no, just there are always new people looking, and there are always people who come and watch our videos back on YouTube later. I think last time I checked, we average around 600 views per video. I don't know how many of those are just me pressing F5. But there are, don't let it think of it as a barrier to entry. If it helps, certainly I still think of myself as a beginner to Rust, and I'm going to subject myself to some pain next week. Well, no, not pain. It's going to be wonderful.
Well, there's an organization that posts a weekly update on Rust articles. I don't know if you subscribe to that, but I subscribe to it every week. And then sometimes they pick up things by themselves, because some of my blogs got put on it, and I didn't subscribe at all, and that's how I found out about them. But maybe we can mention about the YouTube videos and get some more hits, because there's tons of people, thousands of people want to learn Rust, and these videos are excellent resources. Just comparing to what's out there already, they're definitely not the worst, and definitely more closer to the best, I would say.
Broaden our community.
I'll tell you what it's called now.
Is it This Week in Rust?
This Week in Rust. That's right.
Yeah.
Yes.
Yeah.
This Week in Rust. this-week-in-rust.org, and there you can subscribe. You can register, links and stuff.
Right, I'll make it my mission to get the rest of the videos uploaded, and then try and get Alex's talk for next week on This Week in Rust, if it's not too late for that.
No pressure. It's just got to be the best one.
And yeah, and if anyone wants to do like some more beginner talks and stuff as well of some of the classic syntax stuff, I feel like there's always room for doing some more, covering some of the topics that we hashed out with the early chapters, because you always forget as well. I feel like whenever I go back to the early chapters, I'm reminded of some little bit of syntax I forgot. And I definitely, all of us are beginners. I would count myself in that definitely as well. There's always more to learn. So come along and do a talk.
Thank you.
So your mic broke up there, Adam.
No, I was just saying, once again, thank you. This is amazing, mind-blowing. I have no excuses not to learn, period. Like, you know.
You're quite welcome.
Well, yeah. Your excuse could be, I just don't want to. That's my excuse for many, many things in my life.
Well, we're very grateful that you choose to come here, Matt.
Yes, I only half choose to come here because I ignore the C++ side of things.
Fair point.
Alrighty.
So what's next? What's next coming up? Is your talk, Alex? What's it going to be about?
Traits versus concepts.
Oh yes, that's right. Yes. Look forward to that.
Same time next week.
Yeah.
And then we're still, the date for the one after that's not yet confirmed. It's probably going to be 2 weeks after Alex's. If anyone wants to take the slot after that as well, then please let us know, because the meetup only keeps going if people keep doing talks. So.
Well, as I said, I can do the live coding.
Yeah, maybe we'll block that one in for the next one then.
It was basically a command line based to do tool, so you can do to do add, and then you write some message, and you can say done and so forth.
Maybe I'll end up using it as well.
I already do. So.
Nice.
And of course, if you want to add features, I recommend you just go into that code and change it and add features and do whatever you want.
Yeah,
Get the fun back into programming.
Add macros to it.
Yes.
All right, we'll see you all next week.
Cool.
Thank you.
Thank you.
Thank you
next time.
Bye bye.
Bye bye.
Thank you.
Bye-bye. Thanks.